To week 8 of Algebra 1 at home. It's hard to believe we've been doing this for 2 months. Holy buckets. But there's the finish line in sight. We're almost there. You guys have been doing excellent work. We're very proud of you. Just keep on pressing on to the end here. Not too much as we get towards the end. I'll talk about some of that in the little announcements here. This week, just like the last couple weeks, we have 2 tasks. The first task is 18.2. That's the video that you're watching right now. And then the second task is 18.3. There are only 2 more weeks left of material. There's this week, and then next week we have a quiz, 18.1 to 18.3. And so that's it. So we're getting down to the wire here. If you're trying to catch up with stuff, now is a really good time to ramp up that effort, just so you can catch up and be done with everything. Everything must be finished, and we want to make sure that we're done by Friday, May 29th. So if you have things to catch up on, please do that. The sooner you get that stuff done, the sooner you will be done. So for instance, you don't have to wait to Friday, May 29th to get your stuff done. You can get it done sooner if you like. So just keep that in the back of your mind there as we head on forward. Remember, a little reminder here, go back and do or redo things that you feel like you need to in order to gain mastery of the material or to improve your grade. When you do that, please email your teacher. Schoology does not prompt us when you say you haven't done an assignment and it's been like 3 or 4 weeks. Schoology doesn't prompt us that that's now done. So you need to email your teacher. So please do that. I also want to plug one more time, office hours. Please attend office hours. Ask questions, get them answered. Come to office hours. All right, what do we got going on this week? We got a warm up we're going to start with here. I got this kind of filled in already. Remember last week we used the distributive property multiplying. In this particular case, it's a monomial times a binomial. Remember, it was just using the distributive property and some of our exponent rules. So if I take the first term here, 7n times 6n, the blue arc shows us what's going on. We get 42n squared. And then 7n times 3, that's going to be 21n. Moving on to the next one, I have 8r squared times 4r squared. That's going to be 32r to the 4th. Remember, we add exponents there. And then for that same reason, 8r squared times negative 5r is going to be negative 40r to the 3rd. Don't forget that there is an r to the 1st right there. And then the last term is going to be 56r squared. Again, just kind of continuing that distribution. The last one is kind of a beast, but we can do it. So we take a look. We have to multiply the 5x to the 3rd, g to the 5th times the first term. So we get a negative 15 for multiplying the numbers. We get a x to the 6th because there's 2 x's here and 1 x there, plus another 3 x's here. So that's a total of 6 x's. And then g to the 14th. The next multiplication that we have to do, 5x to the 3rd g to the 5th times negative 6x to the 7th g to the 3rd. That the numerical value is going to give us negative 30. And then the x's is going to be 10 and g to the 8th power as we're adding all those up. Next one, we're multiply the monomial again times the 4th term in this polynomial. That's going to be 7g squared qx to the 4th. The numbers are going to be 35, sometimes 5 is 35, g to the 7th, because we got 2 g's here and 5 g's there, x to the 7th, we got 4 x's here and 5 x's there. Oops, 3 x's here, sorry. 3 x's here, 4 x's there. That's going to be x to the 7th. And then that q just goes along for a ride. There's nothing to combine it with. Then the last term here is just 5. So we're going to have 5x to the 3rd, g to the 5th times 5. That's going to be 25x to the 3rd, g to the 5th. All right, so that is just a warm-up of last class. And so now let's talk about what we're going to do for this class. We're still focusing on multiplication. However, we're going to be multiplying a little bit differently. We're still going to be using the distributive property heavily, but now we're going to be multiplying not just a monomial, not just one term times, 2 or 3 terms. It's going to be 2 terms times another 2 terms, or 2 terms times 3 terms, or 3 terms times 3 terms. And that's what we're going to be doing today. So let's dive right in. So kind of some reminding stuff. So what property have we been using to multiply a monomial by a polynomial? We have been using the distributive property. Remember the distributive property, if we have something on the outside of parentheses, all we do is multiply everything on the inside by what's on the outside. And I've shown you this example before. It shouldn't be anything new. These questions here that I have next are not necessarily asking us to do that multiplication, but to ask us to think about it a little bit differently. How many terms should we get initially when we multiply the following, assuming that nothing simplifies? So what that's asking is, how many terms should I get? Well, I have one term on the outside here. Let me get that a little bit skinnier. And I have 2 terms on the inside. So I'm going to do 5 times 5n. I'm going to do 5 times -2. Well, when I do that, I'll have 2 terms in the end, right? If we actually did the multiplication, we'd get 25n minus 10. Well, that's 2 terms. That comes from taking 1 term times 2 terms to get 2 terms in the end. Okay, so next question is, well, how many terms would I get initially here? Well, I have to multiply this 4n times 5n squared, then times -7n, then times -3. And when I do that multiplication, I have 1 term times 3 more terms, and 1 times 3 is 3. So I would get 1, 2, 3 terms in my answer. Again, assuming that nothing simplifies and I can't combine like terms. Okay? So when we use the distributive property, the first polynomial is multiplied or distributed across everything in the second polynomial. Using that same idea, using the fact that we're multiplying whatever's on the outside by everything on the inside, what do you think we would do here? So let's first talk about this. This is a binomial times another binomial. And it's different because before we were just multiplying one monomial times everything else, okay? So now what if I have a binomial times binomial? Well, that's the part that's how it's different, right? I don't have a monomial times binomial or trinomial. I have 2 binomials multiplied together. So the question becomes like, well, how can I still use the distributive property here in order to achieve my goal? And the answer is probably just the way you think you would. All we're going to do is pick on 1 term at a time and go ahead and still do the distribution. I'm still going to have to take this 2n times the 6n, and then the 2n times 1, but that's only multiplying one of these terms across the other 2. I still have to do that same thing to the second term. So that means I'm still going to have to take 2 times 6n and then 2 times 1. Now, to answer the next question, how many terms, I'm going to get rid of this, I'm going to hide that. How many terms would you expect to get initially when you initially multiply here? Well, I have 2 terms times another 2 terms, and if we did the same thing, we would expect to get 4 terms, and that's exactly the answer we will get, okay? So when we take a binomial times a binomial, again, assuming that nothing simplifies, we will end up getting 4 terms, okay? It's still like the distributive property, except for now, instead of distributing one thing across the parentheses like we were before, or 1 term, we're distributing 2 terms across. So let's see what this looks like in action. So I got a bunch of them filled out for us. I want to work through this one independently with you guys. So I have another binomial times a binomial. So we're multiplying binomials times binomials, and we're going to find each product. We're going to do everything by, the first thing we're going to do is use a distributive property, and then once we're done, we're simplifying everything that we can. So I'm going to first distribute this 8p. It has to be multiplied by 6p, okay? So I'm going to multiply just like I've had in the past. 6 times 8 is 48. And then I have p times p, and that gives me p squared. And now I have to take that same 8p times 2. So plus, and then 8p times 2, that's just 16p. And now I got to do the same thing for the next term. So that's a -2. So -2 times 6p is going to give me a -12p. And a -2 times 2 is going to give me a -4. So I had 2 terms I multiplied them together and I got 4. I got 1, 2, 3, 4. All right, so now we always have to check and see if we're going to simplify. Well, do I have any like terms? Well, I have a p here and a p there. Nothing combines with the 48p squared, so that's going to go along for the ride, 48p squared. And then I'll have 16 minus 12, which is a 4p, and then nothing combines with negative 4, and so that's my answer. So instead of having you guys watch me do that for the rest of the examples, I just have them already done, and I'm going to reveal them as we go. So again, the first thing to do is take x squared times x. That's going to give me x to the third. Then I have to take that same x squared times 2, and that'll give me 2x squared. Now I have to switch to the next term, that's 3, and I have to take 3 times x, and that's in blue. That'll give me 3x, and then I have to take 3 times 2 to give me 6. Okay, so again, I'm going to check and see if anything simplifies. Nothing does, so that is my final answer. This one again, binomial times binomial. I should have ended up with 4 terms, so I got to take 4x times 5p. That's this one here in red. 4 times 5 is 20. X times p cannot be combined, so it's just x times p. 4x then times 7x is going to give me 28 for the number, and then x times x is x squared. And now that's done with this first term. Now I have to switch to the next term. So negative 3p times 5p is going to be negative 15 for the number. P times p is p squared. And then negative 3 times 7x, that's going to give me negative 21 for the number. And then px just goes along for the ride. And now I do have an xp here and an xp here, so I can combine those like terms. I'm going to write it in standard form, so I'm just going to try to put the x squared first. So 20x squared comes first. The negative 15p x or p comes negative 15p squared comes next, and then I'm combining 20xp and negative 21xp, and that's going to give me negative 1xp. All right. Next examples follow the same exact format. So what I'm going to do is just reveal these to you to kind of see what the multiplication looks like, and then reveal the answer. So in this one, we combine the like terms, negative 24n plus 18n to get a negative 6n in the middle. This one, there was no combining of like terms, so x squared times x is x to the third. X squared times 6x is 6x squared. 3 times x is 3x, and then 3 times 6 is 18. Nothing can be simplified there. Last one here, number 6, negative 4b is going to be multiplied by 5b. That's going to give me negative 20b squared. Negative 4b is then multiplied by 3y. That's going to be negative 12by. And then I switch to the next term. So negative 6 times 5b is going to be negative 30by. And then negative 6 times 3y is going to be negative 18y squared. I do have some simplifying I can do. The by's can be combined. So I end up with, I'll just get rid of that little thing there. Negative 20b squared, negative 18y squared, and negative 42by. So I think that is pretty straightforward. It's not much different than what we've been doing with our previous lesson. But what if I ramp it up a little bit? Okay, now I don't have a binomial times a binomial. I have a binomial times a trinomial. And if we think about what's going to happen here, we're still going to be multiplying using the distributive property. It's just going to look slightly different. Now, in the last set of questions, we were like, okay, if I have a binomial times binomial, I have 2 terms times 2 terms. 2 times 2 is 4. If we follow that same logic, I have 2 terms here, but now I have 3 terms. So I should end up with 6 initial terms when I'm done. And we will. Let's see how that works. Same exact thing as last time. I'm going to multiply this 4a, but now I'm going to do it times 6a squared. That's going to give me 24a to the third. And then 4a times negative a, that's going to give me a negative 4a squared. And then that same 4a times 2 is going to give me an 8a. And now I got to switch to the next set of terms, 2. So now I have 2 times 6a squared. That's going to give me plus 12a squared. 2 times negative a is going to give me negative 2a. And then 2 times 2, that's just going to give me 4. And now I gotta look, do I have any like terms? So do I have anything I can combine a to the third with? The answer to that question is no, I don't. So it's 24, a to the third. What about my a squareds? I got a squared there, and I got a squared there. I got 12 of them here. I got -4 there. That is going to give me a positive 8a squared. I'm going to cross these out as I go. And then I have a's. So I got 8 and -2. That's going to give me a 6a, and then plus 4. So this is my final answer. So again, not much different. Okay. I'm only going to do one more of the examples. I don't really think you guys need to watch me to do any more than that. So let's get right into it. Let's do, let's see here. Let's just do this one, the first one. I'll have more space then. All right, so you know what? I'm going to do this one here. I'm going to do number 2 because this one's different. This one is 3 terms times another 3 terms, okay? Now, how many initial terms are we going to get out? 3 times 3 is 9, ladies and gentlemen. So how does this one? This one is trinomial times a trinomial. And a trinomial times a trinomial is no different than a binomial times a trinomial, and it's no different than a binomial times a binomial, because all we're doing is still applying that distributive property, right? So let's tackle it. 6n squared times 7n squared. I'm going to start way over here because I need 9 terms. So again, not doing this one. 6 times 7 is 42. And then I have n squared times n squared. That gives me n to the 4th. 6n squared times 6n. That's going to give me plus 36n to the 3rd. Then 6n squared times -5. That's going to give me -30n squared. And now I'm done with this one. And now I need to switch to the next set of terms, the -6n. So -6n times 7n squared, that's going to give me a -42n to the 3rd, plus -6n times 6n, that's going to give me a -36n squared. And then -6n times -5, that's going to give me a 30n. All right, last term here. I'm going to switch the color. Let's go red. So now -5 to everything. So -5 times 7n squared, that's going to be 35n squared. -5 times 6n, that's going to give me -30n. And then -5 times -5 is going to be plus 25. All right. Holy buckets. 1, 2, 3, 4, 5, 6, 7, 8, 9 terms. We didn't miss anything. Now, let's see what can be combined. Anything with 42n to the 4th. Scan it all. No. 42. N to the 4th. Done with that. What about n to the 3rds? I got 1 here. I got 1 there. And that looks like it's it. So -42 plus 36, that's going to give me a -6n to the 3rd. Cross those out. N squares, I got -30, -36. Let's do it this way. Do these. If I have 35n squared and then -36n squared, that's -1n squared. Minus 30n squared, that gives me -31n squared. Now all the n squares are done. Now I have 30n to the 3rd and 30n to the 3rd. One's positive, one's negative. They will cancel each other out, and I just have plus 25. All right, so that's what those examples look like, okay? So I'm not going to make you guys watch me again do those. But again, here I have a binomial times a trinomial. So 3x times the 6x squared, 18x to the 3rd. 3x times the 5xy, that's going to be 15x squared y. 3x times the -7y squared, that's going to give me -21x squared y, or xy squared. And then I switch to the next one. So I got to do my y's now. So -y times 6x squared. Boom, -6y x squared. -y times 5xy. That's going to be -5xy squared. negative y times negative 7y squared, 7y to the third. I have some like terms that can combine. They now revealed, so I got these ones here, the x squared y's, x squared y, those can be combined, and I have the 21x squared, or xy squared, negative 5xy squared, those can be combined to get the answer here. So it's 18x to the third, negative 26xy squared, plus 9x squared y, plus 7y to the third. Number 4, I am just going to reveal the work I have here. Again, it's a trinomial times a trinomial. When you're doing these, make sure you get 9 initial terms. I have it all color-coded here. And then the answer when you combine your like terms. So notice I have it nice and organized here. When you're doing yours, I recommend you do the same thing. All right, so let's get to some application problems here. Okay, let me grab a pen that I like. Deal. All right, so Trina, she's building the garden. And she designs a rectangular garden so that the garden's length is x plus 4 and the width is x plus 1. I'm trying to find the problem I have in my notes here. All right, it says write an expression to find the area of the garden. Well, what is the area of a square? Well, area, it's a rectangle. Sorry, I have a square here. The area of a rectangle is length times width, right? Well, the length is x plus 4, so let's call it this. And the width is x plus 1. All right, well, now I just need to substitute in the length and the width. So what do we got? X plus 4 for the length times x plus 1 for the width. And now I can write an expression for that. So this is a binomial times a binomial. So let's go ahead and work our magic here. X times x is x squared plus x times 1 is x. Then I have to switch to my next value here in the first, or my next term in the first binomial. 4 times x is 4x. 4 times 1 is 4. So now I have combining of like terms to do. My x and 4x combined. So my area becomes x squared plus 5x plus 4. And now that is my expression for the area. So now if I want to know what the area is if x is equal to 4, what do you think I got to do? I got to take this 4, substitute it in there and there. Let's take care of that. Okay, the area is then 4 goes in for x, that's squared, plus 5 times 4 goes in for x, plus another 4. So simplifying that, 4 squared is 16, plus 5 times 4 is 20, plus 4. And simplifying all of that, I get a grand total of 40, and we had a unit of feet, which means it's 40 feet squared. Rock on. All right, we got one more application problem. This one's a little bit more tricky. You might see this coming up later, so pay attention to it. All right, landscape architect is designing rectangular garden in a local park. The garden will be 20 feet long and 15 feet wide. The architect also wants to place a walkway with a uniform width all the way around the garden. All right, so I kind of have this set up in the picture here. It says draw a picture of the garden with the dimension included. So the garden's going to be in the middle, and so the garden's dimensions are 20 feet wide. So I'm going to draw this kind of in a specific way. 20 feet wide from here to here, and it is 15 feet, 20 feet long and 15 feet wide. So from here to here, we now have 15 feet that way. All right, so 20 by 15. There is a uniform garden all the way around. So it says add the uniform walkway. So I already have that in the picture here. And that uniform width, we don't know yet. So the architect hasn't made a decision on the width of the walkway, but we just know it's going to be some value. So we're going to have to put x here. Now, I'm going to place my x's very strategically in this picture. I'm going to put one there. I'm going to put one there because that represents the width of the walkway. One here and one here. One here and one here. Now, again, the reason I'm doing that is because the distance from here to here is going to be x, and the distance from here to here is going to be x. Whatever they decide the width of the walkway to be, it's just going to be right there, right? Okay, so here's what we got going on. The park's construction manager wants to know how much area will be taken up by the whole piece, the whole garden plus the walkway. This obviously depends on the width of the walkway. So we can write a polynomial that can be used to find the total area for any chosen width. So if they haven't made a decision yet, we can write a polynomial based on this. Well, how am I going to do that, right? I have to find the total area of this outside thing. I have to find the total area. So that means I need to know the distance from here to here, right? Well, what is that? I know the inside part is 20, but I know we need to add an x to it and an x here. So it's really 20 plus this x plus that x. How many x's are there? There's 2, so it's 20 plus 2x from there to there. Then the other dimension, going this way, right, total, is going to be that 15 from here to here. But again, I have that same walkway on either side of the 15, right, here and here. So it's going to be 15 plus this x on this side and that x on that side. So 15 plus 2x. And that is going to be the total area of the garden. So I got 15 plus 2x here, and I got 20 plus 2x there. Those will give me the dimensions of the walkway. So the area then becomes, again, the length times the width. And we've just written expressions for the length and the width. So the length is 20 plus 2x, and the width is 15 plus 2x. So this is the same as the last problem, right? We just got to do some multiplication, and we're done. So 20 times 15, that is going to give me 300. And then 20 times 2x, that's going to give me 40x. Inside here, I got 2x times 15. That's going to give me 30x. And then 2x times 2x, that is going to give me a 4x squared. Now, cleaning everything up and writing it in standard form, I want that 4x squared out front. Then the 40 plus 30, that's going to give me 70x plus 300. Now, here's what that architect can do. He can decide any width he wants for that walkway. Say he wants it to be 5 feet wide. Now, all he has to do is substitute 5 in here and 5 in here, and he can find the area of the entire garden very easily rather than measuring what that's going to be. All right, so that is your lesson for the week. Go do cool math stuff now. Guys, we're almost to the end here. The finish line is in sight. You are doing great work. Keep going, and I will see you hopefully very soon. Miss you guys. Hope you're all doing well. Take care.